Good day, folks. Welcome to my YouTube channel. Today I'm doing the work energy and power. It's a Northern Cape province. It's a trial exam 2024. It's a work energy and power question. Let's cut the chase. Now it says a skier of mass of 100 kilograms starts from rest. Very important information. Starts from rest. That means the initial velocity is 0 at point B, at which is 30 meter below point A, right? And it moves down a frictionless curve. That means no friction there. Now to point C. Let's look at that. So a guide comes from there and then is going to that. So that section is frictionless and it is no other force. So this is a closed system. It's a closed system. So the mechanical energy is conserved there. The initial velocity is 0. And then the height, since it's 50 from there to there, so from point B down it's 20. So the difference between 50 and 30 is 20. So it's 20. That makes what? 50 there. Right there it makes 50. So if it's 30 there, that it's 20 there. And then it moves down the slope to that point. So the velocity is increasing there. So there's no friction as well here. As we are told, it's frictionless, no friction. Right? Now, it says here, a skier passes point C and moves up a rough, which means there's a friction here. It moves up an incline, rough plane incline of 30. So we're given an angle there. We do not have a height there. And we do not have a displacement there. Right? We are not told the displacement there. Right? And since it is a friction, okay, let's leave that for now. Now, ignore the effect of air friction. Now, it says here in 5.1, it says, write down the energy conversion. The energy conversion of the skier from point B to C, there's an energy conversion from point B to C. What will be that energy conversion there? It's very important to understand that. If you can see there, it has a height. The height is not equal to 0. That means it has the gravitational potential energy there is not equal to 0. The velocity there is equal to 0. That means the kinetic energy is equal to 0. So the energy that it has there is the gravitational potential energy. And then when it gets to that point there, it has the final velocity that is not equal to 0. That means the kinetic energy is not equal to 0. It has the kinetic energy, but there the height is 0, and then the gravitational potential energy is equal to 0 there. So it's gravitational potential energy to the kinetic energy. Gravitational potential energy to the kinetic energy. Gravitational potential energy to the kinetic energy. That's the answer there. Okay, I'm not going to write it. Now, 5.2, it says write down the term isolated. It's very important, isolated system. The isolated system, guys, is a system where the net external forces is equal to 0. It's a system where the net external force is equal to 0. 5.3, it says use energy principle to calculate the speed of the skier at point C. So as it comes from there to there, we want to calculate the speed. So what we're going to do, this is conserved. We're going to use the conservation of mechanical energy. So it's 5.3. So we're going to say the mechanical energy at point B is equivalent to the mechanical energy at point C. And then the gravitational potential energy at point B is going to be mass, which is the 100 times 9.8. And the height is what? Is 20. Remember, the height is 20 there. Right? Oh no. The height is 20, and then plus the kinetic energy. The kinetic energy is 0 there. So it's going to be 0. Okay, we're not going to put 0 there. We're just going to leave it like that. it's going to be 0. And then the mechanical energy at C here, the only thing that is here is gravitational potential energy. No, the gravitational potential energy is 0 and the kinetic energy is not 0. So we're going to say half times 100, which is the mass, and the velocity, the one that we're looking for there. I hope that makes sense. So if you times that, if you put that in the calculator, you say 100 times let me punch it in the calculator. It's gonna be 1900. It's 19,600, and then this is gonna be 50 VF square, and then we divide by what? By 50. We divide by 50. So when you punch that in the calculator and put the square root, the V final there, it's going to be 19.8 meters per second. So it gets here with a velocity of 19.8 meters per second using the conservation of mechanical energy. Right, now 5.4. Now it says the skier experiences a frictional force of 200 on the incline. So this frictional force here, it's what? It's 200, right? It says calculate the maximum height reached by the skier at point C. So here, we have the forces that we have here as the skier moves up an incline is the gravitational force, which is the Fg parallel, and the frictional force there. So I'm going to use the energy principle here, which is the work, energy, and power, which is the work done by non-conservative, which is that. So what is the work done by non-conservative? What is a non-conservative force in these forces that are acting on this object while it's here? It's the frictional force. So I'm going to do the work done by frictional force. Work done by frictional force is Fk, change in x, cos theta is equal to okay, I forgot here, change in EP. So it's going to be half mv squared minus mv initial square plus mgh final minus mgh initial. Right, so I've done, this is the work done by non-conservative force. So in the forces that are acting here is the Fg parallel and the frictional force. So in one of the two, the non-conservative is the frictional force. So I've done the work done by non-conservative force, and this is this and this is that. Okay, now let's substitute the frictional force. The frictional force is 200, and then the change in x we do not have. Right, the displacement we do not have here. We do not have the height as well. So if you look at that, it's like that. It's a right angle like that. We're gonna use the trig ratio. It's 30 there, and we do not have the displacement. We do not have the height there. So we're going to say sine 30 is equal to height over change in x, and then we are looking for the displacement. So the displacement, when you cross multiply, is going to be the displacement is equal to h over sine 30. Okay, we're going to put sine 30 there. We're going to put sine 30 there. It's sine 30 degrees. So our displacement is that. So in the place of change in x, I'm going to put that. So I'm going to say h over sine 30. And then the displacement of the direction, this skier is going this way, and the frictional force is going in an opposite direction. It's going to be cos 180. So it's going to be cos 180 degrees equal to half. The mass is 100, and then the final velocity. Guys, as the skier moves up, it reached this point with this velocity, which is 19.8. And since there's a frictional force there, the velocity is decreasing. So when it reached this maximum height, the velocity is what? Is 0. The final velocity here is 0. So it's going to be 0 squared, and the initial velocity is going to be this velocity, which is this one. It becomes the initial here. So the initial velocity here is 19.8 meters per second from here to here. So it's going to be 19 19.8 square, plus the mass is 100 times 9.8, and the height final is the one that we're looking for. The height initial, it's here at the bottom. Height initial and the height final. So the height initial is 0. So when you punch this in the calculator, it's going to be negative 400h. How? It's 200. It's going to be 200 times h. It's 200h divided by sine 30, which is sine 30. It's half. It's going to be that. So it's going to be 400, and the times negative 1, it's negative h. And then when you put this in the calculator, it's okay, let me punch it now. It's half times 100 times 19.8 square. So it's 19,602, and plus this is going to be 980. 9.8 times 100 is going to be 980h. F, which is the height that we're looking for, and then this is the height that we're looking for as well. So what are we going to do? I'm going to take this to this side. So when I take that to that side, it's going to be 1000. No, it's going to be, this is supposed to be negative because there's a negative there, so it's going to be negative 1380 h f, and then we have that it's negative 9602, and we divide by negative the 1380, negative 1380, and then our height is going to be 14.2 meters. Right, and then we're done there. And the last question, it says if the angle is reduced to 20, which is this angle is 30, now it's reduced to 30, so 20 is going to be something like that. So do you see the height is going to be smaller? Do you see the height is there? So the height is going to be there now if it's reduced to 20, which is the incline there. Now they said, will the maximum height be greater than or smaller than or equal to? So the answer there is going to be smaller than, as you can see. If it's 20, it's there, the height is going to be there, so it's smaller than. The reason for your answer there, the angle is directly proportional to the height. The smaller the angle, the smaller the height. Or you can say the F net is going to decrease, the F net there, because as the slope is decreasing, that means the acceleration is also going to decrease. So if the acceleration decreases, the F net decreases. Guys, I hope I make sense. Cheers, bye.